next method of factoring is going to happen when a does not equal 1. So as you can recall, we have talked about GCFs. We've talked about factoring when a equals 1. We've talked about factoring completely. So can you find the GCF and continue to factor? Well, this method occurs when you don't know or you don't have a GCF. So if you look, you'll always ask, do I have a GCF? Well, the answer is no. 2, 5, and 3 have nothing in common. And a doesn't equal 1. It's something other than 1. So we're going to use this X method. Okay. In this X method, I'm going to scroll down here. Okay, some of my work is already shown. All right. We draw this X. At the top of my X, I'm going to multiply A times C. So if you can see the equation back up here, that's the first and the last term. So A times C, that gives me 6. At the bottom of our X, we're going to put this B value. That's a -5. So what I'm asking myself is, still, when we factor, what multiplies to be 6 but can add up to be a -5? So we're going to think of the factors -2 and -3. A negative and a negative stays negative when we add. A negative times a negative is a positive when we multiply. We do this X method to help factor. We're going to rewrite our quadratic equation based on this X method. So we'll rewrite our squared term, 2x squared, and then we want to rewrite our middle term. Our middle term we just broke down into a -2 and a -3. And we'll keep C, our constant, the same from our original problem. So this X method was a step to help rewrite our quadratic. We're then going to continue with something called grouping. We're going to group our first 2 terms and our last 2 terms together. So this word grouping, okay, so that's going to be group the first and last 2 terms. So the first 2 get grouped and the last 2 get grouped. So if that's the case, then we're searching for a GCF. So once we group them, we want to know the greatest common factor between these 2 groups. So between 2x squared and 2x, that's going to be a 2x. Between 3x and 3, I'm going to take a -3 out. I want this x value to be positive. So what I'm going to get is this is x minus 1, and this will be x minus 1. As you'll notice, these 2 factors repeat. That tells us we've factored out the correct GCF. We're doing something right. And our final answer, we're going to write as 2x minus 3 times x minus 1. And if we took some time to multiply these things out, well, we would get our original quadratic equation. The back side of this page is blank. I would encourage you to flip it over and try some of these examples with me. For the next few minutes, I'll be doing just straight up examples, so you can end the video at any time. So flip that page over onto the back, and let's look at some of these examples. Let's start with example 13. So go ahead, I'm trying to get this centered for y'all. Go ahead and write down example 13. All right, we need to start with an x. So I'm going to start with my x. A times c goes on top. So if you know what 14 times 3 is off the top of your head, you can write it. But let me grab a calculator. All right, this is going to be a negative 42. Now remember, we're trying to think of something that multiplies but adds. So we want to think of something that can multiply to 42 but add up to get 19. And I get 21 and 2. And we'll make sure that 21 is negative. So I'm going to rewrite this quadratic. I'm going to rewrite it as 3n squared minus 21n plus 2n minus that 14. I'm then going to group my first two and my last two. And I want you to think of some greatest common factors. What's the greatest thing that's in common between 3 and 21? What's the greatest common factor between 2 and 14? And we'll fill in what's left. So this will be n minus 7, and this will be n minus 7. Again, we know we're doing something right when these two factors match up nicely. So our final answer is 3n plus 2 times n minus 7. Okay, and that problem is completed. So let's try 14 here. What I want you to try is I want you to try to get this x by itself. Go ahead and pause the video, I encourage you, and try to complete this x by yourself. So I'm going to get the factors of 15 and 4. I want the 4 to be negative because I'm multiplying positive and negative, and I'm adding. I need a positive 11. So we'll rewrite this quadratic. We're going to rewrite it as 5x squared plus 15x minus 4x minus 12. Again, we're just rewriting this 11x as what we found those two terms to be. I'll group the first two and the last two. My GCF is going to be 5x, and we'll take the negative, so a negative 4. This is x plus 3, and this is x plus 3. Multiply it back out, I can get to those original problems there. And those match up, so I'm doing something right. My final answer is right there. Right. Again, I encourage you to pause the video and try to fill in the x, that information that x provides by yourself in number 15. Again, what multiplies to be 12, a negative times a negative is a positive, but what adds up to be 13, and a negative 13. So we'll go ahead and look at rewriting this. we'll write it as 2k squared minus 12k minus k plus 6. Okay. When you write the order of your middle term, it does matter. You want to try and match up the two values that have the most in common. So 6 and 12, I'm going to get more out of than 6 and 12. 2 and 12, excuse me, I'm going to get more out of than 2 and 1. And you'll definitely know you're right again when those two factors at the end match up. So we'll group these things. I have a 2k in common here, and we'll just take the negative 1 out. So what you'll notice is by matching those up, I'm going to get k minus 6. And I took the negative, that's k minus 6. So that was the right choice because I got two of the same factors there. So my final answer is 2k minus 1, excuse me, times k minus 6. Again, I'll always encourage you to try these on your own. See if you can complete 16 by yourself here. And then replay so you can watch the final answer. And this will be our final example here. So, 9 at the top, 10 at the bottom. What multiplies and what adds? So it'll be a nice easy 9 and 1. 3x squared plus 9x plus x plus 3. We will group our first two and our last two. And that's going to give us a greatest common factor of 3x and 1. That plus 1 does matter. This is going to be x plus 3 and x plus 3. One more time, those matched up, so we're doing something right. Our final factors are these right here. I'm going to show you these two, 17 and 18. But when you see this video in the next second, you're going to just see the final answer. So you really do need to pause this and try it on your own. Just like I said, blink and the answers are there. So I hope you paused the video so you could check your work. This worksheet is on the blog if you'd like to find it, and the answers will be there as well. If you don't check my blog because you're not a student of mine, you could write those 4 answers down, and if you really wanted to, you could message me to see if you were correct. Happy factoring!